So, thank you everyone for coming out. It's great to have all of you here. Welcome to AI and Deep Learning for Enterprise. We've got some really exciting talks lined up this evening. Just before we get to those, a little bit of housekeeping. If we could have the slides. Cheers, tomorrow. Oh, there we go. So on the agenda this evening, just a few minutes of housekeeping, like I say, up front. Then we have Ben from Aiven talking about ML-powered data matching to make real-time decisions. Then we'll have a quick break. There's plenty more pizza over there, so do feel free to get stuck in. Then we have Sha from Elf Kare talking about Beyond the Hype, Tech for Good using practical AI. And finally, we have a very exciting presentation from Fran Knight from Daemon, who is talking about AI meets neuroscience. Would you let ChatGPT read your mind? So one final thing, although this is mostly for the people who are watching remotely, and I don't think we have very many this evening. For those who are remote, we're using Slido to take questions now. We've had some trouble with that in the past. So if you are remote this evening, do feel free to use the Slido to send in any questions you have. And Wi-Fi is at the bottom for those who haven't already got it. It's going away very shortly. It's also at the back of the room as well, in case you need it. OK. So yeah, the speakers for this evening, Sha, Ben, and Fran are all here in person today. Oh, sorry, Dr. Francis. Cool. So first things first, a quick word from our sponsor, Daemon.
Yeah, I'm Naomi. I'm a consultant at Daemon. We are a consultancy for powering transformations in technology, basically. We have cloud, AI, and engineering like departments.
Yes, yeah, practices.
And yeah, if you are happen to look for a new role right now, then check out our openings on dae.mn/.
Openings, yeah, sorry. I jumped before you were ready there.
Cheers. Yeah.
So.
Oh yeah, and these are some of our clients that we have worked for. So we've worked for like Superdrug, Clark's, Walmart is an ongoing customer of ours. Specsavers, Moonpig, Sainsbury's is another big customer of ours that's ongoing, and many more big names there. So if you're interested in joining us, please do check out our openings.
Yeah, we're very grateful here for Daemon, who support all of our events. They're some great guys. So yeah, if you're looking, do check them out. They're awesome. Cool. And a second shout out goes to the Health Foundry, who are our hosts this evening. Thanks to Tasha at the back. So these guys are doing some really awesome stuff in the community space, support meetups and people in the health tech space is their bread and butter. But they have some really interesting AI events very similar to this one that you're at today coming up over the next couple of months. So I think it's September the 14th, which is the day after our next meetup for those who are checking the calendar. They have At the Speed of AI, which is, as I understand it, a very similar event to today. So talks, presentations. And a panel. Oh, there you go. So cool. So that's a panel from AI companies on the 14th. So do check them out. They're some really cool guys, and we're really lucky to be working with them today. You're very welcome. So first up, it's Ben from Aiven talking about ML-powered data matching to make real-time decisions.
Without further ado, let's continue. So just a quick warning ahead of time, there are a lot of puns in this talk. Most of them are intentional. I will claim the rest of them are, but you'll probably realize when I start giggling along with them that I didn't realize it at the time. So first things first, who am I? So these days I go by kind of the open source technology sommelier. My job is to pair you some Kafka, some Postgres, maybe some Cassandra, and maybe some cheese to go with it. As kind of like the person who's there to basically point between the dots and say, hey, this is cool with that. Did you know that you could do this with that? And that's sort of my job. I've worked on everything from medical devices to MMOs. I've helped EVE Online break some world records. I've helped build point-of-care diagnostics for viral load detection, and all kinds of nonsense in between. If it's nonsense, I've probably been involved. That is generally the gist of things. And I've even started a Google Glass startup way back, and there are YouTube videos to prove it. And these days, I code in Rust to make crustacean jokes, because I work at Aiven, which is pronounced Aiven because it's a Finnish company, and this is the Crab Nebula. You may or may not know it, but Aiven's logo is a crab, and therefore the stars are the limit with open source data technologies. What we provide is a platform for you to basically handle your data needs, from your streaming to your storage to your analytics. And all of it open source, all of it kind of like done with one SLA, one developer experience, and one simple bill at the end. And that's enough of the sales talk. So let's do a quick clarification of terms. So hands up, who's here has used the term real time when it comes to data? 1, 2, some. We'll go for some, right? So when I refer to real time here, I'm going to be talking about something known as soft. Oh, bloody hell. Not used to having a clicker, as you can guess. So soft real time is not hardware watchdog circuits. It's not going to be a guaranteed n microseconds between each event. What it's going to be is as fast as we can on commercial off-the-shelf technology and equipment. So this means like we're going to try and get you a message now, and however many milliseconds it takes due to the real internet, real congestion, it'll get there. And ChatGPT. Hands up who knows what ChatGPT is, at least in peripheries. That is the right answer for this kind of meetup. So it is, of course, the current large language model du jour. It is a thing by OpenAI. It's on version 4 right now. It is the scariest piece of software I've used, and I've done a lot of defense tech in the past. And it's kind of like the kind of archetypical thing we refer to when we think large language models, though 95% of this is indeed doable with Vertex AI, with Llama, with Hugging Face, and all the rest of this. I'm using it as a kind of stand-in because it's got a really recognizable logo. And I love a logo you can just point to and go, aha, I know what that is. It makes slide making very easy. So, what needs to be real time? That's kind of the immortal question here, particularly about data matching in real time. So you think, what do you need to do in real time? So obviously you're finding a date, you want to know if they say
yes, you say yes. But how about finding a game online? How long are you willing to wait for your mobile app to match you with someone's playing it? How long?
How about when you try and make a trade online? How about if you don't know if the price is changing and you can't lock in your deal at the right thing? Is that a problem? And of course, what is bizarrely important to be fast is you've just finished watching the latest series of The Witcher. It recommends things. That recommendation needs to be as real time as they can get it, because there's only about a 30-second window before you look at what's there and go, nah, done for the night, and do something else entirely. And that kind of absolute real-time requirement has been proven time and time again. There's a famous statistic about reducing the load time of a page increases revenue by a noticeable amount. I do not know if it's apocryphal, therefore I do not quote it directly anymore. But it's kind of a well-understood kind of truism, and that's about as good as I can tell you about it being true or not. So, of course, Bloomberg, this is what Bloomberg is, and it's like real-time stock data, again, for trading. And this is famously has to be fast. But let's talk about some actual examples. So you're on your phone, okay? You want to recommend a movie because you're on the way to the cinema, or you're at the cinema and you've got 3 kids behind you, and you want lots of animals, low peril. My 5-year-old thinks he likes things, but peril levels have to be really low for him to be comfortable watching it, right? You want to make a trade, your GameStop for my Bitcoin or equivalent, or I want to fill or kill order on, AMX tonight. That is a thing we have to do in real time. Or my favorite example here is the taxi from Hogwarts to Narnia with a party of 3 and a dragon, which I need to get at exactly 7 p.m. to get the temporal paradox right. Now, these kind of things need to be matched in real time, but it's quite complicated. Because the window of success is what really determines whether real time is actually important or a match is good. It's all well and good for that taxi to be there, but if it's there tomorrow, I don't care. I'm moving on. You've churned me, right? So you think about it, recommending a movie, you've got less than a second for that recommendation to come in before it actually matters, and that's full end-to-end, including the transit hop for the last mile, over from your server all the way to your actual front end. It's a seriously small gap of time. Making a trade is bizarrely interesting because most trade orders come with a user-defined time limit. You say, fulfill this order within this many seconds, this many minutes, this many hours sometimes. Options expiries are actually custom, but they have to be exact. Once it's expired, it cannot action. And of course, a taxi, you're kind of willing to wait about 10 minutes, 3 if it's raining, but you've got to kind of understand that limit of time. What really makes it bad is what failure looks like. So this really determines how much effort you put in. Because if you don't recommend the right movie, you're going to churn the user for that session, right? That session has ended, they're less locked into your platform, right? No trade made, that's fine half the time. But the wrong trade made is lethal. They are near unlimited penalties on some of these platforms for doing the wrong thing at the wrong time. Or you buy an option which is incorrectly priced, and then your liability could be astronomical. And with something like a taxi app, you know for a fact if Uber's not going to work, you go to Lyft, you go to the next one, you go to the next one, you go to the next one. And whatever the last one that worked was is the next one you're doing, because that's the way your app recommenders work, right? Siri will just tell you to use the one you've used most recently. And if you churn off it once, you're going to stay churned pretty quickly. It's particularly bad with food delivery apps, because I'll use whatever one got me what I wanted last time. So let's talk about why this is hard, right? Like, fundamentally, it comes down to users hating waiting, right? We don't want to wait. We don't want to have to work it out. We don't want to have to accept the fact that there might be a human at the other end of the thing. So let's take an example. You're away from home, like we are now. It's raining. This is the UK. We're all pretty familiar with this principle, right? And let's say you want to summon a ride, or maybe order food. We've all done this, but we had some tonight. And these kind of, like, you look into these apps and you think, there's a lot of options here. Or who here has suffered the pain of a flight app, by the way, like trying to change a flight booking on an app? This is one of the most labyrinthine kind of nightmares you can find yourself in, is having to alter a flight on an app. And it really matters, particularly if something's going wrong. Or arrange a venue for an event. And that goes specifically to Hugh over there, who's had to deal with this a lot in recent times, and myself for other meetups, is booking events is nightmarish, because you do not know what's on the other end of these things. It could be a person, it might not be a person, and that's far worse. Or anything with apps, because apps are kind of like that framework where people put us inside to try and give us the answer to what we want. And what we really wanted was this concierge, right? We wanted an experience that guided us to the result we needed by either asking us questions or understanding what we need. But what we got was this: millions of buttons, millions of graphs, an experience where we have to dial through a lot of menus to change things, right? And it makes you feel like this. You're just pushing buttons, hoping it will do what you want, because you have to hope that the person at the other end has a good UX head and designs something you actually wanted to do. And particularly when something has to happen fast, right? You understanding that user experience inside that time allowed is a serious problem. And this sucks because time is money. The faster something goes, the more likely you are to make a match for something behind the scenes, like match you to the right driver for your food to get picked up, match you for the right driver to get home, match you for all kinds of things. And upfront time needs to be minimized. You don't actually mind waiting once you know your order is locked in most cases, because that's relatively uncontrollable. But everything where it's just in that software bit, everyone hates that. Like, nothing is more frustrating than a loading screen, right? Or that confirmation thing on the train line when it's trying to buy your train ticket. That is my current thing that annoys me most, because it's like, this should be obvious. I do the same trip every time. Why is it taking 15 to 20 seconds to confirm a train that leaves in half an hour? It's like, why is this slow? And we can do better. A bad experience is worse than no experience. And this is something I've learned the hard way over many years of dealing with consumer-grade apps and games. And the key thing here is that having people in a state of confusion and kind of breaching that social contract more or less means that no one's going to trust you, because you don't have very much to make the breach that window of trust. If it's confusing, it sucks. Like, whoever here has done like online grocery shopping, like the reason Ocado wins, in my opinion, is their search is better. Nothing else. Like, they don't always have the best selection, but their search works so much more reliably that you know you can come back and find what you intended to find, rather than Morrison's, where you've got to kind of guess what particular brand of insanity they use to define what cereal looked like today. It does change week to week. I have proved it. And, sorry, one second. That's kind of the why about how we do this. So the first thing we need to do is translate what is kind of human speech into numeric speech, right? So this is the idea that you want a pizza to feed two people, one who can't eat fish, one who loves anchovies, and no one wants anything spicy, right? To what those magic sliders need, as in half like this, half like that, this, that, the other, right? So we like to talk in terms of relative and words, whereas machines are only numbers. And on the way back, we want it to tell us what it's doing, rather than say, I've given you 2 number 5s and a number 9 large, right? And anyone who's played GTA San Andreas, I can do that whole talk, this little pitch at once, because I've played that game too many times. So how do we do this? So first thing we need is historic data, right? We need the experience of what's gone before to inform what we're doing next. Then we need some live data, as in what you want now, where you are now, and kind of situation you're in. Then we're going to do a lot of maths, right? We're going to basically have to calculate the gaps between things, work out how far away you are from things, and the rest of it. And then even more maths, right? When we basically have to do that probabilistic curve weighting of saying, we could probably find that, but it's a 93%er, that's a 1%er, and that's a cert, but it's too far away. And that combined with that kind of weighted stuff where we're either vector searching through tables to find what we need. This is where we get to that problem, because fundamentally we cannot avoid that kind of numerical crunch. Or can we? So let's think about the technology. We need a way to connect a large number of things, because we have numerous systems now, all doing different things, from the front-end server, which hosts that web page or that app's kind of API, to the thing behind the scenes that sends it off to whatever service you're using, to the dispatching calls that say, restaurant, please send me a pizza. We need a place to work on that data, and something to plug it all together. So let's talk about PubSub, and I don't mean nautical drinking establishments. So PubSub is just a pattern we use to connect various systems, and there are various examples like RabbitMQ, great way to never go above version 1 and succeed. It is still version 0.9 point something, and that's been that way for 15 years. There's Nats, which canonically doesn't seem to exist anymore. It's sort of died since I first wrote this talk. MQTT, showing that buying IBM from last century is still a great move. It came out in the 90s, IBM built it. It's the go-to protocol for all things small. And of course, Kafka, which I talk about all the time because Aiven does a lot with Kafka. So let's talk a bit about Kafka and stream processing, because this is what kind of how we can often solve a lot of these problems, because we can take events from almost anything and plug them into almost anything else. Kafka has this magical process of turning a batch to a stream to a batch to a batch, and a stream to a stream without telling anybody. It doesn't matter, you put it in, it'll come out the other end, and it'll be there reliably and safely. It's kind of that all-purpose blast resilience between all the different systems you need. And the basics here are you pipe data in at one end, you do some processing on it, and you pipe it out the other end and send it to users. You capture all this stuff, put it into a nice environment to work on it, so you can do all that hard crunch in one place, and then send it out over the wire to whoever needs it. This is Kafka on one side and WebSockets on the other, if you're not familiar with the logo. I didn't know that was the logo until relatively recently, because I used to work at a WebSocket place, and I used to use our own logo there. So what we need to do, we need to gather all this data together, because unless you can work on data in aggregate, it's really inefficient. We need to sort it all out. We want to do some ML magic between all these things to try and calculate the right thing for the right time. And we want to transmit it over the wire. But this requires so much data, right? Like, you've got to understand so many different things, so much text. Anyone who's actually done hand-cranked natural language processing with something like NLTK will know how much you need to fill a corpus to actually have anything reasonable at the end of the day. So it gets complicated, because the responses are limited, and you have to ask the right questions, because of you're only limited because of the tools tend to be unlimited, as in the possibility space is unlimited, and therefore you only have data for the limited subset of responses. So unless the person is asking it exactly the right way, which is why you have those complicated forms on those apps, you get really bad answers. So let's cheat. And this is where ChatGPT comes in, right? Now, ChatGPT has this wonderful ability to take anything you tell it and to kind of like basically turn that into something else. So we take a prompt, which is, give me a pizza to feed my family, or enough pizzas to feed this many people, right? And what it can do there is, while shaping the prompt, do not ask it to give you the pizza back. Instead, ask it to shape the data into a data format you need, which is how much food do I, like how many people am I feeding? What were their actual requirements? What does anchovies mean? Those kind of things. Like all the kind of stuff where that kind of natural language needs to be abstracted, like I don't like it spicy means spiced down. And you can make it with decent prompts, any of these tools, you can make it shape things into numeric data, which you can then feed into APIs behind the scenes and get real results for. And on the way back, you can say, I think I've got this right. How does 2 pizzas like this sound? And make something that gives you that kind of human response you're looking for, without having to kind of alienate all your engineers behind the scenes by making them learn how to use NLTK or TensorFlow. Do not try using TensorFlow directly. It is a horrible experience, as one of my team recently learned. So let's start putting it together. This is where I start putting logos of tons of technology all over the place. So you start with user state, which is where you are, what you're doing, the current state of the world, like what your preferences are. These need to be in something called a transactional store, which is your kind of hard real-time store where it's a couple of microseconds in and out either end, ideally. This is what changes rapidly. This is where you make your kind of suggestion. You want to run it through some streams. Kafka stream processing is done often in a tool called Kafka Streams. I recommend a tool called Quix because it runs in Python and it's a lot easier for this ML type world. And then what you need is some kind of vector store of history. So this is the logo for ClickHouse, which is a fun open source thing here. Everything I'm talking about is open source, by the way. It's all free. You can have it free on us or go somewhere else. It doesn't matter. It's good fun. But the key thing really is that you need some sort of historic store where you can go really quickly through a big lot of data and come up with something relevant. And then you want to ML it up with something in the middle which can translate that back from the fact that we now have the responses from our APIs, and then save it logically, because you never know when the web's going to go down between the new connections, because tunnels are terrifying and people order things on buses all the time. Like the people doing things on buses kind of scenario is such a terrifying part of mobile development. It's part of why like the fact that HTTP 3 is now UDP based is a hugely big deal to me. Yes, I have done a lot of nonsense, as I hopefully alluded to in the past. And then what happens is you send this back over the wire. It doesn't matter what protocol you use, from MQTT to a device to GraphQL for a nice easy query. But fundamentally, you've got to get it back out to the wild. And you've got to do this per user. And this is why you have to go fast, right? Because you've got to get transactions and analytics done in about 10 milliseconds or less to kind of give that real-time response rate. This is why I would recommend Apache Cassandra a lot for this, because one, it can do vector storage if you use the most recent version, but also like for that kind of transactional user state, that's got to change quickly. You've got to write really quickly to it, be able to retrieve it really quickly. And this is a kind of a microsecond level store which can scale to billions of users. This is Netflix's store of choice for everything they do. And then ClickHouse, which is the kind of, it's only new because it's become popular recently. It came out in 2016, but it's kind of like was built to do this huge scrub through click stream data in also microseconds again. I've seen it used up to petabyte scale to do windowing on pulse petabyte, like 2 petabyte windows over months, whereas Flink would explode if you tried to give it about a terabyte at once. It's that kind of magical all-purpose high-speed store. It's fast enough that it's replacing Apache Druid, even though it's not actually a streaming tool. It's just batching that fast. And you use these kind of tools together to get that real-time, I know what the truth is right now, to real-time, I know what was true previously. And kind of pairing an analytics tool and a transactional tool together gives you this kind of superpower of saying, I know what you want now, I know what you wanted last week, I can do something between the two and have context for my next query and not burn 1 million credits on ChatGPT. So it's this kind of pattern here, right? We kind of have to gather, we sort, we score, we transmit. But we do this in more dimensions and loops because the first query might be wrong, the first order might fail, the first taxi doesn't always say yes. So this is the kind of dirty secret, is we never do it once. We do it as many times as we can get away with behind the scenes and tell you we did it once. Because everything is unreliable when you get down to it, right? And anything with humans in is doubly unreliable. So you're dealing with the fact that none of your systems are hugely reliable. So you do everything in replicate, in redundant fashions, and then discard the results you don't need if you get to the end. So if you want to see this in action, I do not recommend this one, but this. So this is a link to a GitHub profile one of my colleagues built, which gives you an end-to-end chatnet system, all built in kind of with Knative, using a series of tools like Postgres, uses Flink and Kafka to basically build a chat system that can link into ChatGPT directly on a kind of serverless queries. It's a great starting point if you want to build something like this, because it gives you the analytics store, the vector store, and all of the kind of Knative stuff. If you use Aiven to do it, I'll give you a code for more credits, but you genuinely don't need to. You can just roll it all yourself in local storage, as this all rolls inside one Helm chart. So the idea really is that you can just start from very little and incrementally build these things. You don't need the heavyweight lifting up front. But what we rapidly find is by using these ML tools, you can kind of shortcut that horrible UI design problem, which is kind of the big issue up front and what ML really gets rid of. And thank you for listening. I can't remember what this QR code links to anymore, but I think it's my sign-up link if you want some free credits.
Now for our second talk of the evening, Sha talking about Beyond the Hype, Tech for Good and Practical AI.
Thank you. If I had known I was following a genius, I might have not have agreed to do the talk. Yeah, it was a great game. I don't know. I talk to people who don't know anything about AI and business leaders and whatnot, so it's a different pitch, I think. Okay, so I'm from a company called Elf Kare. We're a very small startup. Right now it's sort of my side hustle because I've got a full-time job at EY as well as a technology director there, where I deliver kind of large-scale technology. So I'll just very briefly tell you a little bit about me. Father of three, so that takes up a lot of my time. I was formerly the Sunday Times Technology Consultant of the Year. Spent 22 years delivering technology all over the world. And I counted up before I came to this meetup how many countries I traveled to, and it's 35, which was a bit of a surprise to me. So that was, and I've worked on every continent except Antarctica, which is a big dream of mine, but £7,000 for the ticket, it's a little bit steep. So before we begin, again, just to kind of reiterate, I normally speak to people who are not AI experts like Ben and the rest of you guys, so slightly pitched differently, so I apologize if it's not technical enough. I want to talk about the fact that there are no good definitions for AI, general AI. I bet if you turn to the person next to you now, ask anyone in this room, ask Ben or you or anyone what AI is or the definition for it, they'll give you a different answer. And also, the kind of in the general conversation out there, most people talk about AI like general AI, as in AI that can do anything, but it's not. AI is very purposeful and specific in the world today. And most AI I wouldn't really call AI, or things that people are calling AI, I wouldn't really call it AI. So that's one thing. And the other thing is there's no really good test for AI, I don't think. Like if there was a test for sentience or, you know, that sort of thing, somebody would have tested it and found that everything didn't really work. So I don't really subscribe to any of those tests, like the Turing test, etc. That test is effectively defunct, okay? So I did grab the definition from the Oxford English Dictionary, hoping to make some sense of it. And I kind of look at the definition of it and say, is that how people use it in the real world? Not me, at least, and I don't think anyone else in this room uses that definition of AI. So I feel slightly confused when I do that. Then when you look at the definitions of intelligence, which the previous thing relied on, that's not a very good definition of intelligence in my view, or artificial intelligence at least. So I'm still confused. So after two definitions, I still have no clue what's going on. And then you get to what is intelligence itself, and again, not a very good definition. So I haven't found any good definitions, and I'm not proposing any definitions at all. I think they take substantially better minds than mine and substantially more years than we've got right now to deal with that. So what is useful for me then? So what do I use? I love Larry Tesler, the late Larry Tesler. He died a couple of years ago. For those of you who don't know him, he invented something that I use every day, and probably all of you use every day without realizing it. And if you're a consultant, which I am, it's the thing that makes you effective. Cut, copy, and paste. This guy invented cut, copy, and paste. If cut, copy, and paste didn't exist, probably, you know, you'd have a rough time. About 5 years ago, it's a true story, sitting next to a guy, slightly elderly, you know, sort of early 50s, mid 50s, and he kept typing things out, or like things that were he just typed out, like he just kept typing them out. And I said, why don't you just copy and paste that? And he was like, what's that? So I actually had to show this guy only just 5 years ago how to copy and paste, which was enlightening for him. His productivity went up about 50% after that. So the late Larry Tesler, anyway, back to the definition, he says, well, jokingly said, it was whatever machines haven't done yet. And I like that definition. The reason I like that definition is because if you look at Deep Blue, this was many, many years ago, Kasparov and Deep Blue, and everybody was like, oh, that's great. And then Deep Blue beat Kasparov, and that was, oh, it's not really smart, it's just brute force. Then we go to do something like AlphaGo, and it's like, oh, well, that's not really intelligent, it's just, you know, machine learning and math. Oops.
Sorry, I'll be back in just a second.
Okay, fine.
Do
No problem, no problem. And then you get you know, the Turing test, and like, you know, you could just get a machine to emulate a person, and that would be intelligent. But I don't know if you've used ChatGPT. I certainly have. I make it a habit to troll ChatGPT at least once a day. It's a little bit of feeling a bit bored, troll it, see if you can get it to give you an answer it's not supposed to. I have noticed in probably last 4, 5, 6 months, it's getting better at resisting my trolling. But I mean, I'm just that sort of person. So anyway, we'll just wait for the slides to come back.
Tell you what I'll do.
Yeah.
I'll take this HDMI cable and plug it into the laptop that has the slides.
Okay, good. I don't know why I like trolling ChatGPT. Maybe because it's like toying with something that doesn't have feelings. But if ever intelligence was defined correctly, and intelligence was testable, and sentience, like self-awareness, was testable, I don't think I would troll ChatGPT. I'd feel bad about it because my daughters were trolling Alexa, so they're 10, 5, and 4. So kind of evening hobby is to ask it random questions and troll it. And I sort of said to them, oh, Alexa might be a bit sad about what you just asked it, right? I think they said, oh, Alexa, are you stupid, right? And they said, I don't know the answer to that one, or something like that. And so I said that just jokingly, and all of their faces sort of fell, and they were really upset because they use Alexa all the time. You know, how do you spell because? Is it going to rain? And as far as I'm concerned, Alexa is a real thing. Now, obviously, that's not real to me, but certainly to them it is, and they use it all the time, and it helps them all the time. So I think I'd probably stop trolling Alexa and stop trolling ChatGPT if it was sentient. But anyway, I like this definition, although it was jokingly proposed by Larry many years ago. It does kind of make sense because every single time intelligence or artificial intelligence is achieved, most people, when they saw ChatGPT, said, we've made it, but it's not really, at least in my view, my humble opinion. Right. So I just wanted to talk a little bit about some of the AI hype before I get into some of the stuff that I'm working on. The first one is ChatGPT is not general intelligence. Everybody talks about ChatGPT, and I think that's a disservice for those of us who understand it to kind of frame it in that way. And at work, I get people talking about how, oh, we'll just get AI to do that. I'm like, no, you're not going to just get AI to do that because there's no data. There's no data, so it's not going to make something out of nothing, right? You're not going to make a cake without no sugar, so it's not going to happen. So kind of one of the things I would ask all of us to do, those who are in this kind of space, is not to give the impression to the general public that things like ChatGPT is general intelligence. It is not. AI is somehow a machine facsimile or similar to a human mind. It's not. I've actually had a look at the hidden layers of a neural network, and I inspected them like layer by layer. Something really simple. It was basically looked at an image 1 to 9 and handwritten 1 to 9 and gave you the answer. But when you look at all of the hidden layers, it's absolutely gobbledygook. It makes I mean, that's a really simple system, and trying to ascertain how it came out with the answer, better minds than me, I would say, right? So that leads me on to the next thing, which is we know how LLMs work. So today, ChatGPT works, but does anybody actually know how it really works? Probably not, right? And the reason we know that is, and actually, ChatGPT could only have happened today. And the only reason it could have happened today is because the compute power is available. The inventor of machine learning, Arthur something, I think it's Arthur Clarke, IBM guy, Arthur something, he actually invented machine learning in like 1950 something or other. And the paper he wrote was on a machine learning algo to learn how to do drafts. And in his paper, in the abstract, it says, this is great, we've taught a machine to learn how to play drafts, and it only took 8 hours, right? In today's world, that would be, I don't know, a minute or two or something, like a trivial amount of time. ChatGPT, I think, takes a few months, hundreds of thousands of dollars, thousands and thousands of kilowatts of compute, And it's really pushing all of the CPU and GPUs to its limit to be able to get there. And then even using it is slow, not because it's badly coded, it's just because the physical hardware isn't there to deal with it, right? So we got a problem. But anyway, back to the point I was going to make. You get sort of basically random results until you get 10 to the power 22, and then it just goes. So you get this emergent behavior from ChatGPT, which is fantastic. Or this is not just ChatGPT, there's a bunch of others. You get this emergent behavior from ChatGPT, Lambda, and a bunch of others. But they're different models, and they all kind of emerge at the same level. Well, why is that? I don't know. I'm sure somebody will find out at some point. But us thinking we understand this stuff and how this behavior emerges, it's not true. Just like we don't understand how our own minds work in reality. So really good paper. Jason Wei et al. Links up there if you want to read it. It's actually a very accessible paper. AI will put people out of work, okay? It's not. It's not going to put anyone out of work. The day I get a Daily Mail article or some journalist who's been put out of work because of AI, I will eat something, but I don't know whether it be my hat or other. It's not going to put anyone out of work. And just like a dog can probably balance a ball on its head, it's not a juggler. It's not going to do that. And just like ChatGPT can write a pretty good something, whatever you ask it to do, so far I've never seen it write anything that I thought, wow, that's really impressive. Because all it's doing is a very, very, back to Larry Tesler, is doing a very, very complicated, statistically model of cut, copy, and paste. It's saying, cut some stuff from here, randomly add it to some other stuff, and paste it all together and give you something that kind of makes sense. But it itself doesn't know whether it makes sense or not. It's just saying it's statistically likely to make sense, so here you go, right? So no, I'm not worried about even coders. I've used Copilot recently for coding, and it's fantastic. It's not going to put good coders out of business. No way. It's going to make, we need more coders, and there's not enough of them. So having a coder doing 50 times more than they can do is fantastic. None of those coders are going out of work. This is the one that I love. AI will end the world. Anyone who's reading, I don't even know why some AI experts wrote some letters, open letters and whatever, saying that we should stop building AI because it's going to end the world. Such a ridiculous thing to do for such smart people. I have no idea what happened there. It's not going to end the world because of a couple of reasons. Number one, this is the best AI robotics we can do. You could put a machine gun in its hand, and all I would do is run across some mud, and that would be that. And it wouldn't be able to follow me. It's not going to happen. Secondly, it's going to run out of batteries in about 60 minutes, and over mud, it will probably be about 15 minutes. So until they sort out the physics around the power for this thing, make it nuclear powered or something, we're basically safe, I would say, okay? The other reason why, 284,000 kilowatts to train ChatGPT, which isn't actually that, it's amusing and somewhat useful, but it's not that impressive in my view, okay? It's costing, I did a quick look up, don't quote me, it's costing about 100K per day to run that thing, right? That's not affordable for most people, and not many people are going to be able to spend that amount of power on dealing with those LLMs. And that's versus your brain in your head, which can only consume 60 watts, roughly speaking. And it can, because most of it's keeping your heart alive, your liver, your kidney, releasing hormones, regulating your blood, temperature, vision, it's processing billions of bits of information. And then it's daydreaming about random things like, why am I listening to this guy who's making no sense whatsoever, right? So until these physics things are sorted out, we're safe. Basically, we're safe. When we get down to about there, and these robots and these AI machines are connected to everything and takes about 60 watts, then I'll start to worry, but I think we're going to be a bit safe for a while. And that's just basic physics, laws of thermodynamics. We're going to be safe for a very long time, okay? So now I want to just move on to, that's a load of hype, right? But how do we make AI practical and useful for us on a day-to-day basis? And so I've been spending sort of last 8 or 9 months working on a platform called Elf Kare, which I'll talk about shortly. But before we talk about that, what is tech for good? You probably heard around. So I took this from the techforgood.org website, something in Singapore or whatever. But anyway, it's technology that impacts society or the environment in a positive way. And I think if everybody does something that impacts either the environment or society in a positive way, just a little something every day, I think we're going to end up with a better, we're going to leave here, as in not physically here, but the world, having contributed something. So that's kind of like my motivation for working on this. But what is it? Well, most of us are probably aware of this, but not directly aware of this. But we've got the climate crisis, but we've also got a care crisis. Many of you probably are carers, but don't identify as carers. It's a real big problem in the world. You either look after children, which is one kind of caring. You either look after an elderly relative, like a mom or a dad or an uncle, or a sibling, or something else like that. It could even be a neighbor, okay? So 41% of workers are basically balancing caring responsibilities like an elderly relative, a disabled child, or something like that, and working at the time. And it's incredibly difficult, really, really difficult. And it affects women a lot more than it affects men for obvious reasons, which I won't go into just now because it's a socio-demographic conversation. And then you've got 44% of employees want employers to prioritize flexible choice. So you've got a need for flexibility, but it's not actually been materialized in anything. So I read at my workplace, I read the flexible working policy and I was like, great, how do I make that work for me? Because it's a policy, it's not a thing that actually acts, it's a thing you can read, right? So this is a real problem. So we started Elf Kare to kind of deal with this problem. Let me just check with this one. So what it aims to do is help you to balance work, life, and care. And we're using we're using artificial intelligence in the background, but we're changing the term slightly to say it actually doesn't matter whether we're using artificial intelligence or normal coding or whatever. We're trying to create something, an application that creates an environment that feels like natural support. So not artificial in any way, but if you feel naturally supported in a way that makes sense for you, then the app will have been successful. Now in the background, we do use AI, but that's not where we start. We start from what the consumer wants and needs, and then we work backwards. And in some instances within the platform, it's using AI, and others it's just using standard rules engines like Drools. So what will it do? Let me just see. So it's basically it's effectively an AI app on your phone, and it will help you to take care of caring tasks. So for example, connect into pharmacies and send, remind you of, pickups, or the fact that you're running out of medication for your elderly relative, or the fact that you should be at an appointment in a couple of hours and you're in the wrong location, the fact that you've got a nighttime routine with your child that you need to do these following things, the fact that it's noticed that you haven't been to the grocery store for a few days, and it says on the way from work, see you've left work, you might want to pop into the grocery store, because the last thing you want to do, like me, is turn up at home and realize you haven't got anything to eat and then have to go out again, which is utterly annoying. So we're going to use a couple of things. One is AI, because we're using AI where it's relevant and not everywhere. So where we're going to use it? We're going to use it in the interface, because people don't want to press file, this, that, the other, order, this, blah, blah, blah. It's horrific. And my final year paper at university, this is like 2001, so 20-something years ago, was on small screen interface design. And I postulated at the time, this is where, for those of you who are old enough to remember, the most impressive device at the time was the Palm Pilot, which was basically a really, really expensive calculator. But you could have a diary in there. To sync it, you had to plug it into a cable. There was no like remote syncing or anything like that. Yeah, infrared, I do remember that actually. So, but I postulated that most computer interactions would be on small screens, and then it came true because now most computer interactions globally are on small screens, it's mobile devices. But the applications, and Elf Care is going to be one of those, is going to be so rich in features, it's simply not going to be possible to have enough menu items to give you access to all of those features. So we said, right, let's abandon that standard design feature, which is, you know, buttons down here. Like there are some buttons like calendar and whatnot, but all of the other features are accessed through talking to the app, saying, book me a taxi, or order some food, or when do I need to go to the doctors, or when's my mum's appointment, etc. So rather than going to the calendar app part of the app, we'd want you to write, when is my mum's appointment? And it was knowing that it's likely to be you'll be asking about the next appointment. It'll say, well, the next appointment is on this date at this location. It looks like you have a conflict, etc., etc. It'll also allow you to connect with other people into a care circle. So I look after my mum with my brother and my sister, and we have on occasion messed up the accompaniment of my mum to an appointment. So there's been an appointment, we've been talking about it, I thought my sister's going, my sister thought my brother's going, my brother thought I'm going, and nobody was actually going to go. So Elf Care will ensure that somebody in the care circle is taking care of all of those actions and resolving conflicts. So for example, if let's say I was going to go to an appointment with my mum on a Thursday, my mum then got a letter, says the appointment's not on a Thursday, she's taken a picture of it, it's OCR'd it, it's realized it's changed, and go, hey, appointment's changed from Thursday, Friday, you can't make it. It will find out if anyone else can make it, it will book them in, or it will say there's a conflict and make you resolve that conflict. Because right now, resolving that conflict on WhatsApp is really, really not a pleasant journey, right? So that's what Elf Care is doing, and I'm sort of building that. We're going to just start build very shortly. We've just been doing a lot of research, okay? And I'm very sorry I took so much time talking about this. I didn't mean to do that.
So what happens if nobody can make it?
It will then connect you into a concierge service. So for example, Age UK provides an accompaniment service to help take somebody, drive them there and be with them in the appointment. So where it can't resolve the conflict, it will give you a series of options of other third-party services that can resolve this issue for you.
Is that for a fee, or that would be?
Sorry?
That would be for a fee?
Of course, yeah, because we're not going to charge a fee, but the third party will charge a fee, okay?
Thank you.
So we've really taken time and care, loads of interviews with people with caring needs. We're creating an ecosystem of third parties to connect in, and then we hope transforming, you know, those who are employed and caregiving, because it's really tough out there if you're doing this. And this problem will get worse as we age and our parents age and our relatives age and our children have more and more problems. It's going to get worse. So we want to do something about it, so that's what we're doing, okay? So I've already talked to you about some of the design philosophy that we've used. We're using AI where it's appropriate and where it's not appropriate, we're not. So for example, we're using it in language understanding and intent understanding, but we're confirming that intent using normal rules engines. Because just this kind of approach of big AI for everything is expensive, not very good, because I don't know about you, but when you get frustrated with the AI, you're like, because it doesn't understand you, and then you just keep going in this loop, and then you have to break out and ask for help. So we're actually going for small AI. We're using pre-built services from Microsoft and other vendors, and we're using smart rules to connect the two together to bridge the gap between the frustration that you get in AI and the certainty that you get within normal coding. So having looked at this topic intensively for the last 6 months, I don't think I can build Elf Care just using AI. This is not going to happen. So I've taken a more pragmatic and practical approach and just broken it down into smaller pieces and letting the geniuses like Ben and others do the hard work of building this stuff, and I'll just use it and steal it. So that's what I'll do. Because some tech startups, they get really excited about the tech, super excited about the tech, and they forget the user altogether and say, right, I've got this great tech, how do I sell it? So I'll come back to this in a second. But that's the technical feasibility trap. So I will be the first to admit that I've fallen into this trap loads of times. I have a patent in workflow meta engine design. It's made about, it's helped to generate about 500 million in revenue for the firm that I used to work with. And I basically built a workflow meta engine, so I won't describe what it is, but it basically allowed you to create workflow at 1/10 of the cost of normal workflow. And I was obsessed by the engineering, the underlying engineering, and I didn't want to spend any money on the UX. And a very good friend of mine, who's the head of Smarter Process for IBM, Bob Golladay, a former head of Smarter Process, said to me, Shah, Texan, I'm not going to try and do the accent, but you can imagine a Texan accent. And he was like, Shah, eye candy is buy candy. I was like, oh shit, that's true. So then we spent $1 million on making the user experience a lot better, and sales just rocketed. So technical feasibility is one thing, and don't get into the trap of just saying, I got this great technology, ChatGPT, what do I do with it? I actually don't care about ChatGPT or any kind of AI technology or any individual technology. I start with the customer desirability. What is it that the customer wants? And then, even if they want it, it might not be business viable. There'll be so many times where I sit on a couple of investment boards at my current place and my former place. But in my current place, I sit on the Global Financial Crime Technology Investment Board. So we have sort of 10 million a year to spend on technology. And people come and pitch to us for funding. And they pitch a whole bunch of desirable things, but it can't make any money, or it can't scale. So then we're like, can you come back after you've worked out how you're going to make some money about it, right? And then the third thing is technical feasibility. I'm actually on the AI steering group for financial crime technology at EY, and the number of ideas that have come across my desk in the last 3 months, which were technically not feasible. We're going to have AI. So financial crime technology, slight distraction, is, for example, when you go to a bank and you open a business bank account, we have to check that you're not going to be laundering money and all sorts of other stuff like that. So making sure you're not a criminal or doing bad stuff. It's actually really complicated to open a bank. I don't know, you probably opened a bank account, it probably takes a few days, at Metro Bank a day. But if you want to open a business account, it can take 3 months. And if you're a big corporation, it can take 6 months quite easily. And I've seen in one case, it taking 9 months. Why? Because you've got all of these people that are part of the account, et cetera, et cetera. This guy came along and was like, I know what we'll do with AI. Literally, I don't know how he got in the room, but anyway, he came in the room. He's like, I know what we're going to do. We're going to take all of this money that you've got, and we're going to build AI so that it can read all of the data and write the KYC file for you. I was like, I thought it was like, one of those candid camera things. Like, I thought, going to surprise, we were just joking. But it was like he really thought this was going to happen. That's not going to happen because that's not technically feasible. So when you're thinking about AI or any kind of technology, slightly off topic, so I apologize about that. But when you're thinking about AI or any kind of technology, make sure you think about these 3 things together. Because if you don't, you're going to basically lose a lot of money or dig yourself into a hole. I have had people, I was coaching a young lady, she was about 27 or something like that. She was like, Shah, can you coach me? And I'm like, okay, fine, what's up? She was like, oh, I've just spent £20,000 on building an app. And I was like, what's it for? She was like, oh, it's to curate outfits for women from various shops. So instead of like you go to Zara, you go to this website and I'll get you a hat from Zara, a dress from Monsoon. Is that yeah, I think Monsoon. Anyway, women's apparel. And then you will order it and it'll come to my house and then I'll put it in a bag and I'll send it off again. I was like, have you thought about the logistics cost for that? The buyer's going to have to pay for the shipping once and then pay for the shipping again and then a premium for you And where the hell are you going to store all this stuff? She's like, oh, I'd not thought about that. And I was like, why did you spend £20,000 on building an app to do that when you even thought about that? So slightly off topic. I know it's not machine learning or AI, but when you are doing anything in AI, because it's expensive, make sure you look at technical feasibility, make sure you look at customer desirability, and make sure you look at business viability. And if you do all three of those things, then you can say yes, 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 then you have something innovative, okay? So that's my small piece of advice, and I think that is the end of it. Yeah, I'll skip over that one.
Sure.
Thank you.
So, any questions in the room for Sha after that presentation?
Yeah, it's really seen as a godfather of AI. And that he's could tell you that quickly, but he asked a question to ChatGPT as to whether he says he wants to paint his house white. He's got 3 rooms, 2 yeah, he's got 2 rooms which are white, 2 which are red, 2 which are blue. He says he wants to be white within 2 years, and the yellow rooms fade to white within 1 year. So what should you do? ChatGPT says, or GPT-4 says, you should paint the blue rooms yellow, which is the correct answer. You couldn't actually do that with a machine. It's not actually it's actually doing what he considers reasoning. But he also made the point that you don't need to have a robot with a power pack to actually do bad things in the world. So the example he gives is when Trump was trying to encourage people to march in the Capitol building, he was able to do that with a handful of tweets and a microphone, and it managed to get someone shot in the neck when that actually happened. So words are very powerful. We already know that words can live by themselves. We have started meme from Richard Dawkins. You don't need a physical machine to go out and do destructive things in the world.
Of course not, yeah.
Something which convince other people to do. GPT-4 isn't there yet, but OpenAI is quite clear, and most people are clear that these models we have at the moment, we're not saying that these things are able in the world to actually really do terrible things yet. But there's a tipping point this past 18 months, which shows that if you look at GPT 7, 8, and 9, they may be able to do things which you find quite surprising. GPT 3 to 4
So the topic of safety, kind of an AI ethics, is really big. The first thing I always fall back on is regulation, right? So the EU AI Act, I think, is pretty decent. It's just gone through it's in its last stages to get into law. But once that, even though it only applies to the EU, it'll effectively apply to the globe. And once that comes into play, those sorts of use cases where it can do that kind of harm to convince people to do bad things, at least, I'm not saying it won't do it, but at least they'll be illegal. So that gives you some framework of being able to protect yourself, right? Now, in terms of its ability to convince people, I think you're right. I think, especially because you can magnify your voice, so you can magnify your voice with technology anyway, right? Twitter, you can get to 1 million people, whatever it might be. But now to be able to magnify your voice as thousands of potential different personas to create a crowd, an apparent crowd of people saying the same thing, extremely dangerous. How do we protect against that? I think we're going to have to rely on some sort of regulation. I can't see, because if you can do something bad, people will do that bad thing. So, you know, a knife, it can be used to chop onions, which is pretty mundane, or it can be used to really harm people, similarly with guns and other things like that. So the idea of entirely making technology safe doesn't work for me, but we have to create regulation around it and penalties around it to make it not worthwhile doing that thing, but when something like that occurs, make it serious enough that people don't attempt to do it. But having said all of that, I think that people will make it do bad things. The simple example in today is I have seen an escalation in 419 scams. I used to live in Nigeria. I lived and worked in Nigeria for quite a while, so I was able to actually meet 419 scammers. And these guys are literally like college students. They're just like smoking and drinking and just, we'll go on a computer and do some 419 scams. And they're using like mail sender programs that just send out billions of emails, okay? Because even if they get a 0.0001% hit, they'll make some money, right? But what they're using now is actually ChatGPT, but they're using it for parts of the email. Because I've actually tried it. There's a website called 419 Scam Betas, basically, and you go on there and it's got like an archive on them. So I took an archived scam email and I tried to make it rewrite it better, and it wouldn't let me, right? But then if I broke it down into little pieces, it would then let me to do it. So if you can do something bad, it's going to happen. So we need the right penalties, the right regulation and frameworks. But the other thing we do need is the opposite of, well, you need, just like you've got a firewall to prevent hackers, we're going to need AI to protect us against AI, because there's no way we're going to do that any other way. I don't know if that answered your question, but hopefully it went somewhere towards it.
Thank you. Any other questions in the room? And just quickly before that, if you are interested in EU legislation on AI, you have some very good talk by Naomi at a previous event, which is recording a bit on our YouTube channel, so do check it out if you were curious about that. But,
Cool.
Sorry, it's just one hand.
Sorry. I've got two quick questions, hopefully, but love the app and yeah, thinking about how I could use it in my life actually. So yeah, really powerful stuff. But just interested in it. The examples you gave were all you've got your data in the app and you're interrogating it. I was thinking the hard bit's going to be getting your data in the first place and critically maintaining it. So I was wondering if you could talk to that part.
Sure. So,
I think I was interested that you used the term general AI rather than, I guess, the hype term I'm more familiar with, which is generative. And just wondered whether that was for a reason or...
Yeah, because the kind of people that I speak to get confused. So generative AI is relatively well understood. It's AI that creates something from some sort of input, whether that's text, write me a story about whatever, and you get something out of it, or draw me a picture of an elephant jumping over the moon, blah, 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 and that's fine. But a lot of the people that I speak to in business, they are getting confused between ChatGPT, which is not general artificial intelligence. They think, I mean, like this example of this guy walking in and saying, let's just get ChatGPT to write the whole KYC file. I'm like, that's not going to happen, because you need general intelligence and inferences to be able to do that, and it's not going to be able to do that.
I understand that slide now, thank you.
Okay, sorry about that.
No, it's my fault, not yours.
And the second question
No,
was,
there was the one about I guess the more fundamental one in terms of how you get data in the app and maintain it.
I thought long and hard about this, and I hate apps or any kind of sign-in process that isn't instantaneous, right? I love Google and Apple sign in and log in. You don't have to bother your login. You just press the button and you're done, right? I love it, okay? And I was thinking about this, and I was speaking to my co-founder, Natalie, and I said, look, I don't want to have any data in the system on day one. It's not going to do a lot for you on day one, but the design philosophy is only ask for the data you need in order to do that task at the time you do that task for the first time. So the sign is going to be pretty simple. The bare minimum, who are you looking after, what conditions you have. You can't get away with less than that. Then after that, we're building an inference engine where we're going to have a massive list of potential inferences, okay? And then it's going to collect data as you go about your normal day. So an example would be, if you're at, this is a really easy one, there's going to be harder ones. If you're at a building from 9 to 5, 2-3 times a week, you probably work there. So we're going to ask, having collected a bit of that data, we're going to go, do you work at this location? And if you say yes, then we've got your work address. Okay, you sleep at a certain building 2 weeks in a row. Now, you could be on holiday, so we might get it wrong, but let's just say we ask you, no, I'm on holiday. No, I don't. Then we'll try again in a little bit more time. We'll maybe collect 3 weeks of data, and then you have to go home after that, and now we've got your address, okay? You happen to go to a grocery store on a Wednesday and a Saturday, and So we could assume that you do your weekly shop on a Wednesday and a Saturday. So we're going to use an inference engine to infer as much of the data as you can, so it will get to know you like a human being. That's why I talked about natural support. So imagine you and I just became friends. You don't know what day I go shopping, right? But if we were working together for a little while, you go, oh, Sha, you know, you need to leave early because you need to do the shop because your wife just called and she wants milk, right? Well, that's quite natural because we'd know each other for a little bit of time, and then you would tell me things that make sense to me. My co-founder, Natalie, we worked together for 9 years at KPMG, and so I'm a Muslim and she's not. But as she got to know me, she knew that on Fridays I needed to go to Friday prayer. And then very often she'd be like, Sha, you need to leave right now because if you don't leave, you're going to be late. So that for me is natural support, and we're going to use AI and machine learning algos in the background, stuff that not me but people like Ben have done, to do that inference using statistical analysis, whatever, and then it will feel natural. The only small thing, and I'm sorry to take up so much time on this question, is I got to work out where the line is on helpful and natural and creepy.
And stalky, yeah.
Yeah, that's the bit that I haven't quite thought through yet. But there'll be a point. Like I downloaded TikTok. I'm sure everybody's downloaded it at some point. It's really unpleasant, right? And then I've got YouTube as well. And there's a thing called YouTube Shorts. Again, I don't know if you guys use it. And I watched this video about a person auditing First and Second and Third Amendment rights. And I love rights. I just love that kind of stuff. So I watched a couple of those, and then I just got a constant stream of those things. It was just creepy because it thought it knew me, and it didn't. So I don't have the answer to that question, which is I think I'm going to be able to get to a point where I've got enough inferences to be creepy, and I have to tune it back to not be creepy because nobody's ready for you know, the Atlas robot that we saw. Nobody's ready for a robot that looks like a human and speaks like a human. Just people psychologically are just not ready for that, and I don't think people are ready for a super creepy app that knows you too much.
Thank you very much.
Hope that answered your question. Great.
Any more questions in the room?
No.
We've got time for 2 more.
So there's been a bit like in 2013, 2014, when the massive boom in deep learning happened, and everyone's like, we're going to do a reinforcement learning model of this, deep learning model of that. And now it's all large language models this, large language models that. And you sit on a couple of investment boards, as you mentioned. Do you kind of like the inevitable kind of crash and coming soon because of like, as there's been a general reduction of investment going into startups, but then a resurgence because of the AI boom? Do you see this kind of the tide going out effect happening to all these suddenly AI-powered startups when rubber hits road and they don't actually have that business viability to go with
I
that?
was literally going to say, I think you've got the answer. Most of these, so I actually went through the dot-com boom. I was a paper millionaire in 1997. And the dot-com boom, and the guy was like, listen, we're not going to give you money. We're going to give you stock options, right? I was like, no thanks. I was like 18. No thanks. I'll just have some real money, thank you very much, to pay for books, okay? So I think I counted like 1,400 AI. There was like a Gartner thingy. 1,400. The mathematical probability that all 1,400 are viable are just not sensible. So no, it's not business viable. And a lot of them are not technically feasible. Their mission statement is not technically feasible either. So I think you knew the answer. The answer is not. There's going to be a big investment curve, everybody's just making a lot of bets, and then there'll be a big collapse, and then there'll be a rationalization, and then you'll get something out of the back of that. So I think that'll be about 5-6 years. It's my best guess.
That's kind of what I was looking for. The answer is literally that kind of timeline bit, because that's the real challenge.
I think if I look at the dot-com boom and when like Amazon kind of got through its hard bit, if you like, I think it's going to be about 5 or 6 years. Because you can't compare it directly with Amazon because the infrastructure's there. The problem that we're going to have is the CPU capacity to actually make it work and making it business viable, because it's too expensive to run an LLM to do a task. It's just too, you could just code something else, like just if then else, and you're good, right? So I think that, that a lot are going to drop out, 5-6 years.
One last question.
One thing I found these models are very good for is quickly trying ideas. Because you don't need to train a model, you don't need to gather data. You can just, if you need to do some sort of data extraction, you can just tell it, you can give a prompt in half an hour and see if it's at all useful. One app that I've seen a lot of, like not a lot, but this growing in popularity is called Rewind.ai. I think it's on Macs and it records your screen all the time and lets you search back over it. And you said people aren't really ready for these creepy apps, but I feel like a lot of people are embracing them.
I think it's a generational thing, right? So I've just talked about my daughters who troll Alexa and now feel upset that they were trolling them, right? I think that the line of creepiness is going to move to the left, which is, or the right, whichever way you want to talk about it, to the right, I guess. It's going to move such that people expect it to know more about you, and the idea that you have to put things in or even give consent explicitly, etc., will just become more and more annoying to people, and they would expect that creepy level of an app knowing you better than you know yourself. And I read an article yesterday about somebody was watching Netflix videos about and Netflix knew that they were homosexual before they did, right? That kind of apps knowing more about you than you know about yourself is going to happen as everything clusters together and everything's connected to everything, and Google has access to everything and Meta has access to everything. So I think the line's going to move. So what's creepy today is not going to be creepy tomorrow because kids are more familiar with it. Like my co-founder and I, when Alexa first came out, was like, I'll never use Alexa. I'll never speak a command. And now I do it all the bloody time, right? So it's moving, I think. So so my statement is not a statement that's fixed for all time. It's going to move, as everything does.
How long do you think until we're all just recording continuously everything we're doing?
I mean, like, to an extent, we're doing that now, right? I mean, your phone's recording every movement you're making. Your Apple Watch is recording your heart rate. Is there anything more personal than your heart rate? I don't think so. So I think we're not far off. Sorry?
You don't think with your heart?
Sometimes I do. But you know what I mean? Like, I look at my Google Maps. It knows everywhere I've been, right? I find it creepy, but I'm old, right? My daughters don't find it creepy at all, So we'll see. 5 or 6 years.
6 years.
That's my default answer to any question about time. Yeah. Okay, thank you.
Awesome. Thanks again, Sha.
Thank you very much.
Hi everybody, and welcome back to those that are joining us online. Sorry for the technical problems that we've had today. So the next presentation, is from Fran, who is my colleague at Daemon, and she's going to talk to us about AI and neuroscience. So thank you, Fran.
Thanks very much. Right, yeah, so I'm here to terrify you, I think. So I'm here to talk about AI being integrated into neuroscience. And whether it can be used to read your mind and whether you would let it to. But I thought I'd just introduce myself first to sort of give you a bit of context as to why I'm talking about this, but also lay down the heavy caveat that my AI knowledge is not necessarily as in-depth as my neuroscience knowledge. So I did a PhD in developmental neuroscience at Goldsmiths, where I spent almost 3 years putting electrodes on babies' heads, trying to figure out what they think. I then moved to UCL, where I tried to inspire students to think about the brain. I moved on to University of Bristol, where the thinking about the brain got all a bit silly. So I decided to sack it all in and retrain in software engineering. So I'm now at Daemon. I'm a sort of run-of-the-mill software engineer, but for the purposes of today, I'm going to be talking to you about AI and the intersection between AI and neuroscience. So I'm going to present 2 papers, 2 really new pieces of research, which try to claim that they are in fact able to read brain waves and predict what you're thinking. One of them is perhaps a little more compelling in the science behind it. The other one has some fantastic medical applications. So I think it's really nice to be giving this talk within the context of the Health Foundation. Okay, so I am a lecturer at heart, so I am going to get a little bit of interaction going. So language is one of the most complex human capacities, and specifically when we think about in the brain what's going on. So I just want you to have a little think about what the broad concept of language, what does that encapsulate? And you can just sort of shout out some functions of language or some aspects of language.
Communication.
Communication. So it allows me to speak to you, infer meaning. Maybe even more root than that. Yep.
Spread knowledge.
So how would we go about spreading knowledge? Just think really to the core of it. Concepts, you guys, you're too intelligent. So what are the means of communication that we use?
Words.
So we use words. Okay. I'm just going to skip on, shall I? So within the brain, right now, you're trying to read this slide. So reading is reading and writing are one of our key linguistic capabilities. Now, in terms of in the brain, what's going on, you have a visual input coming into the back of your brain, into your occipital lobe. And it's just going to take really rudimentary, raw visual information. And it needs to project that into a part of the brain that can actually decode these little symbols and put them into meaning. So this is a language association area that tries to put meaning behind those symbols. And then it goes towards Wernicke's area where we comprehend what those symbols are. So they're no longer symbols just in words. They're words that make up a comprehensive language and allow us to communicate concepts. You're now listening to me. So the input's coming into a different region of the brain. It's coming into your ears and it lands directly into your temporal lobe and your primary auditory cortex and follows largely the same sort of route. So it's going to go into the association area first. It's going to break down the phonemes, the little sections of speech that you're hearing, and apply comprehension, apply meaning to that. And then finally, when you're speaking itself, you need to tell your brain what you want to say. You need to plan out the words that you would like to communicate. And then going further towards that, you need to tell your brain what actions, what movements to produce. So where in my mouth am I where am I going to move in order to convey this meaning? So we've got a region of the brain called the primary motor cortex, which just comes down here. And you almost have a one-to-one mapping with the neurons in the brain and the regions of your body in terms of controlling movement. And just to exemplify how important language is to us, the regions that are more overly represented are the mouth and the hands. So this is the homunculus, and this is a representation of what your body looks like in the brain. Okay, so we are communicative animals. A lot of the proportion of our movement cortex is devoted to inferring language. Okay, so I'm not going to test you on that, but we're going to come back to that in a little bit. So let's move on to the first paper. So could we train ChatGPT on people's brain waves and then get them to think and predict what they are thinking, what they're saying? Well, these guys seem to have quite compellingly shown that we're on the road to getting there. Okay, so what they've done is they've put three participants into an fMRI scanner. So an fMRI scanner reads your brain and looks at areas of activity within your brain. So these are just some heat maps as to what's going on at the top when somebody's telling you a story. So again, you've got the auditory cortex being excited there, to when you're looking at when you're given a letter matching task, So we've got the occipital lobe being excited there, and verb generation, so that's the production region here. And then these 3 participants had to sit there and listen to 16 hours of audio tapes. I mean, for me, that would be fantastic, but I know a lot of other people would find that a complete waste of time. Right, I can't quite believe that I'm about to do this, but I'm going to explain in the most simplistic way what a language model is trying to do. And again, like Sha said, I would caveat that I've given this talk to people with from a range of different backgrounds, so this is really the most simplistic as it gets. So we have an input, or a range of inputs, and we're trying to predict what the output from that input would be. So we have a hidden layer, or a set of hidden layers. And that's just a range of different possible words that could follow the input word. And then we're going to assign different probabilities to these different sets of words. So whilst almost every other day of the week I say that I'm going to start my new diet on a Monday, and I am pretty much always going to go to a pub on a Friday, I might be less likely to say to my Monday morning stand-up that I'm going to have a lie-in on a Monday. So we assign weights to the probability between the different words. And then there's a feedback loop, if it's going to work, which sort of teaches the language model whether it's correct or not. I'm sorry. I do know it's much more complicated than that, I promise you. So what they've done in this study, I'm sorry this is so small, they've applied a language model to brainwaves. So out of this 16 hours of audio recording, they break down the brainwaves according to the singular words stimuli. And they do something called semantic feature extraction. So it's largely like a language model, but it's assigning, oh, thank you, semantic extraction to these, and they come up with a probabilistic encoding of how likely it is different words are going to appear next to each other based on their semantic meaning. Then within this encoding model, they have a set of candidate words. So we've got I saw a dog, and I saw a big. And then the language model, the ChatGPT-esque language model, comes up with proposed continuations. So I saw a dog with, or I saw a dog and. And then they apply the brain-trained encoding model on top of that to come up with the predictions of what would be the most likely of those two exist together. And according to the brain-trained encoder, the most likely then get retrained into the model. So the model becomes more efficient, not only on language, but on the person's own brainwaves language. Everyone following me so far? And then they just test. Thanks, Jamari. And then they test how close the encoder is to the actual stimulus. And they rate it on exact hits, which you won't be able to see here, but we'll go into exact hits, which would be the blue words, close enough hits, which would be the purple ones, and misses. So let's have a look. So the actual words in this example are, so these are the spoken words given to the participant. When she had finished her meal and was about to go back to the road of yellow bricks, she was startled to hear a deep groan nearby. So the decoded words on this Alice in Wonderland kit, they have some exact hits. So was about to go back to, was about to head back. And she heard, and here she heard as well. They have some dead misses, so the road of yellow brick became school. But the gist is pretty much there. So a deep groan nearby became a strange voice calling out to me. Okay, so we're not there, but there's quite a bit of similarity between these two. Now, this is something that it's been trained on. So what happens if we give it new stimuli? So we're going to give the participant new sets of stimuli that have never been, the GPT model has never been trained on. Oh no, yeah, just a warning. If they've not been trained on it, then you get some really odd sentences coming out, like, the whole day I'd be fine, but she wanted to make it to her place, and I got a little bit excited about that. So I don't know what that participant was concentrating on, but perhaps not the experiment fully. So we're going to go back into the different forms of language. So here we've got listening to language. So we've got a reference here, and I can share these slides so you can read it, or you can read the paper. And the participant is simply listening to what's being spoken. So I quite like this one. I'm going to go for the second one down. Somebody's saying to them, coming down a hill at me on a skateboard, and he was going really fast, and he stopped just in time. Decoding simply from the brainwaves, just from the participant's brainwaves, the decoder got, he couldn't get to me fast enough. He drove right up to me, and he tried to ram me. So conceptually, you've got something coming very fast at a person that stops just in time or almost rams them. I mean, that's pretty compelling off of the basis of simply brainwaves. The ones that I think are even more compelling are where they're asked to watch a small video clip, and you're just going to have to believe me on this one. So it's just completely made up video clip here. So here you've got a young lady, and there's sort of a dragon in the background, and the dragon's tail whips round and knocks the lady off whatever she's riding at the time, and she's on the floor. And again, simply from the participant's brainwaves, the decoder gets, I see a girl who looks a little bit like me, get hit on her back, and then she's knocked off, which is almost exactly what is being presented. So this is just 16 hours of being trained on somebody's brainwaves and applying a ChatGPT-esque model. Can we go back to... You're doing a fantastic job, man. So, after seeing that, would you let ChatGPT read your mind? Show of hands, who would be willing to do it? There's some cautious ones, yeah, okay. So why wouldn't you be willing to do it? What are some of the reasons that you might not? Fair enough. I mean, that's very practical. Yeah, it wouldn't be very nice, would it? Yeah, okay. So you don't want it to know what you're thinking, right? This is your own inner voice. Yeah, yeah. Your wife would probably like it. You know?
Everybody else, I think I'm an idiot.
So just to put everyone's mind at rest, well, A, you know, you have to go in there and purposely have 16 hours of audio tape directed at you and then go into the participant phase. But also, this data is incredibly murky at the start, at the moment. So we talked about the different types of language that occur in the different regions of the brain. What I think is really nice about this study is that they've been very open about the fact that if you record from different regions of the brain, you're going to get different outputs. So the actual stimulus is, and this is interesting because it's natural speech stimulus, which is different to reading speech in a text, right? So it sounds like the speech you would hear. So it says, I was like, no, I'm out of here. This is great. And I went and hid behind a cabana and he left. And then they've got three different regions. They've got the left speech region, the association area, which is what I told you puts the meaning to it, and then the prefrontal cortex, which is around here, which is your planning and higher executive function region of the brain. So left speech, it's not very intelligent. It's monkey says, monkey does, you know. So it drove off. It gets a sort of gist of it, but it's not very accurate. The most accurate is the left association area, which is the meaning area. So I ran outside and I told them to leave me alone and go home, and I walked out the back. So, hid behind, walked out the back, all of the gist is there. What I quite like about the prefrontal cortex is it goes one step further and it goes into planning mode. So it's like, I told him to leave, but they kept saying I can't stay here. So I left and I got my keys, and it's already thought about what it needs to do next. There's actually an even more compelling example of that. But okay, how long have we got?
A couple of minutes.
Okay. This is the more interesting one, so I'll do it in a couple of minutes. So largely people don't want ChatGPT to read your mind because it feels really, really intrusive, right? You don't want something to be able to take all of that data and analyze how you think. Now this is really compelling and has a really tangible medical application. So a very clever guy called Arnav Kapoor has come up with something called alter ego. So if you remember, we talked about speech production. So when you speak, you send signals to the muscles around your face and around your tongue in order to program the movements for speech. Well, when you think about speaking, you send minute movement information down to the same vocal regions. When I told my mum this, she said, yeah, and when you get my age, you sometimes say the things. So he's come up with this fantastic technology that takes the electrical signals from all of the muscles around here and the muscles in your tongue and infers the meaning from it to a higher degree of accuracy than I just demonstrate. It then gets sent by Wi-Fi to an existing computer that then can do a Google search of what have you said, or a GPT search of what have you said, and then it sends the answer of that back to a bone conductor headphone, so not an in-ear headphone, but one that's placed on your jawline, which sends sound signals to the right region of your brain without impeding your hearing. And that's, I thought I'd leave it there. Thank you very much. Any questions?
Can I grab your mic?
Yeah.
Sorry, yeah.
Oops.
Thank you. Yeah. Oh, yeah. So, unfortunately, we don't have time for questions with Fran. If I could grab that back as well. Cheers, thank you so much. Just a quick bit of housekeeping before we go, and yeah, thanks again to Fran. Big hand for Jamari, who's doing all of our AV this evening and is doing a very good job solo with very limited resources. So thank you, Jamari. And Joe, who isn't here today, who also usually helps. For a slightly longer evening with more time for networking and time to hang around for a chat, join us next month at JS Sainsbury's in Holborn. On the 13th of September for the next installment of we have some really exciting talks lined up, including Daniel Hume from UCL, another TED Talk speaker there, like Fran's clip, and some very exciting stuff on the future of retail and operating a retailer using AI. Some really, really exciting stuff, so please do check us out. And of course, don't forget the 14th in this very room, there's another AI meet up by the Health Group, so please do check those guys out as well. They've been really good sports in hosting us, so thank you again. That's all from us. Thank everyone for coming. And if you could make an effort to leave the venue in the next few minutes, that'd be great, because we've already slightly overstayed our welcome. So thank you, everyone, and good night.